way it works. Okay, so I'm Sourav Pati. I've been working for Echo Energy as a senior developer currently, and I'm really excited about giving this talk on Apache Kafka. I think recently it started really gaining a lot of popularity in the industry. Although the title is Kafka for Microservices, but I want to begin with some of the complexities that we today have in when we do a lot of data integration. Now, some of the complexity that we see is recording of systems. So, what I mean by this is that suppose you don't have a microservice or RESTful web services, but we have many different sources, Postgres database or NoSQL database or any kind of different source or CSV files, and then we have similar entities, say profile entity, getting profile entity from Facebook or Twitter or LinkedIn. How do you maintain those the entity states or know what is the status of entity, where do you from where it is coming, those things. It's possible, but then there are a certain amount of complexity in it. Then keeping data in sync is also kind of hard when suppose you have one web application sending data to a microservice, then microservice stores the data in one database, say a SQL database, and then you want to have some sort of search index where you want to do some type ahead feature, just quickly get the data. So you want to make sure that your data is in sync in two databases at the same time when you store the data. Achieving this also, there are a certain amount of complexity. And there are other issues when you have ETL process. How do you scale out them? There are tools have been using in the industry for years, but as year goes by, we're getting a lot of more data, and there are times when you may want to scale out things. The question is that how easy to scale out them. Other than that, processing those data is also a bit of error prone when you have those ETL tools in terms of how do you validate the data, how do you make sure that your data, if you have some sort of transformation and you want to write some calculation where you want to have some sort of test, how easy this process. There are a certain amount of error is error prone. So I think these are the questions that is addressed by Apache Kafka very well, and that's probably one of the reasons that is gaining a lot of popularity in the current time. So other than this, if you have microservices, service A, service B, service C, the interprocess communication among these microservices. So if there are various ways. One of the most commonly used is HTTP, using HTTP protocol. So if you have a service A and suppose you want to call some to-do service or some external service, you'll probably, if you're using Spring Framework 5, you probably use something like this. You have a client and then you do a get.uri, you give the link, you make a get call, and you get the data from a different service. So service A is calling service B, you get the data. Now this is all great if you have, when you're doing a read operation with the get method. But now if you have a post method or put method, so you make a post method and your service A sends the data to service B, and HTTP is stateless, so it forgets that something happened. So there is really no way to know what happens and where the data goes, right? On the get operation, your user can just refresh the page and makes another get call and get the data immediately. So these are the problems that I think calls for a different approach, like some sort of message broker. You might think of using something, some RabbitMQ or some sort of other messaging system which solves these problems, but I think there are certain drawbacks they also have that Kafka is able to solve, and I won't go too much in that. That's debatable as well, right? So Kafka is able to solve this problem. So let's learn about some of the why Kafka is doing it so well, and how Kafka works internally in the architecture, in terms of architecture. So Kafka has concept called cluster and broker. The cluster is something is a logical name of multiple nodes or multiple machines when those machines are connected to each other. So you will have a node which they call it broker. Basically, it's a machine, one single machine. Then you have another node which is connected to another broker. So broker 2 and broker 1 together made a cluster, right? And then if you want to scale out, you immediately spin up another server that joins this cluster. So you have now 3 machines connected with each other. You have a cluster so this is how they are actually solving the horizontal scalability, giving this opportunity to scale out, right? Now, then there was the Kafka's clustering and broker. Now, other things that they have is something called topic, partition, and offsets, right? Now, topic is basically a, sorry, I guess my, so topic is a logical name. It's a logical namespace under the hood. So you would usually, the easiest way to think of a topic is like a database table. So you have an employee table, which data you want to create a topic, and mostly the most common is you would create a topic called employee topic. There are various other ways to create topic, and there are a lot of blogs out there, but I think the most common is that you create a one topic is like for a one entity. Employee could be one entity, right? So these topics are only, it's identified by its name. So you would give a name and that becomes your topic. But under the hood, topic is split into multiple partitions. So the partitions is the one which actually stores this data. And that's the real thing of Kafka. The partition is always ordered. And this partition is ordered. So when you have multiple messages, these messages are stored in the partition, and they also call it sometimes as log. So it's very much like, other than application log, it's like a database events. That's what the event comes into the picture. So, and each messages in the partition gets an increment ID, is very much like a primary key that becomes the offset. That's what they call an offset. So how does this broker and topic works? So you have 3 brokers, and suppose you have one topic you created, topic A, which has 3 partitions. And you can actually, you can configure how many partitions you want for a particular topic. So for this particular example, topic A, suppose I told Kafka that, hey, I want 3 partitions. So these 3 partitions will be distributed among multiple brokers. Now, if you have a topic B, which has 2 partitions, then these 2 partitions will be distributed among 2 brokers. Now, the Kafka, the way there's a concept called fault tolerant. So they say that, okay, Apache Kafka is fault tolerant. So what it means is that when you create a partition, you say, hey, I want replication factor equals to 2, meaning that you want a copy of the same partition into multiple nodes as well. So what happens is, in that case, when you have a message comes to one of the broker, it immediately, if you have replication factors equals to 2, then it immediately makes copy into 2 other nodes. So if your broker 1 goes down, then the data is still available from other brokers. So that's how they are achieving the fault tolerant mechanism. So producer and consumer. Now in Kafka, actually very much anything that gives data to Kafka is a producer, anything which receives data from Kafka is a consumer. Kafka doesn't push data to anybody, Kafka stored the data, consumer asks for the data from Kafka. So how does this work? So you will have a Kafka cluster where you have a microservice. You get a producer API. Kafka has created some libraries that you store in. If you're using Java, you probably use some dependency, Maven dependency repository. You just put it in your POM file, and your microservice is ready to write producers. So your producer pushes the data to Kafka, and then you have consumer, multiple consumer can consume that same data from the same, from a particular topic. So you may want to store the same data in Elasticsearch, and then you can have another microservice which is consuming the data and then pushing to some other data storage. You can easily maintain the state of the entity and give the entity to multiple data storage. The consumer has a consumer groups concept. Now, suppose you have one consumer consuming subscribe to one particular topic. The topic has multiple partitions, right? So when you have one instance of your consumer, it joins in a one group. You have only one single instance. So this instance is now gets data from all these partitions, partition 0, 1, 2, 3, 4, right? Basically 4 partitions, 1 to 0 to 3, right? And then if you spin up a new instance of your consumer, it joins the same group, then Kafka will make sure that the data is distributed among these two consumers. And that helps in terms of balancing load, and you probably will have microservices running on Kubernetes with 3 nodes, stuff like that. And then if you have another consumer comes, consumer 3, 4, then Kafka will make sure that your data that is stored in partition 0, 1, 2, they go to the different consumers of the same group. Now, if you have consumer 5, but you don't have partition 5, then one of the consumer is going to not getting any data from the partitions. So that what we learned from there is that we should not be having more consumer than the number of partitions. Otherwise, one of your consumer is going to stay idle. It's not going to receive any data from the partition. And I had a situation where I was testing. When I was testing, I had one topic, and I see that one consumer is not getting data. I said something is wrong happening, and then later I found that this is how it works. Okay, so the topic will do a little bit of deep dive here, how the data is stored in partition and how it works. So Kafka, like I said earlier, that topic is a logical name, which suppose in this example, we have 3 partitions. So you have partition 0, which will have a message comes with a offset starts with 0, then offset starts with 1, the second offset, third offset, like that, you get the partition. And then you have another partition which also starts with offset and gets all this message appended to each other. And then you have partition 2. So this is how Kafka stores these logs. This stores these events in their partitions. Now, when message comes to one of these partition, suppose partition 0 and the position 2, so this message will get a ID, like 02 is going to be the ID of this partition, this message. Okay, so we saw some of the basic fundamental of Kafka. Now, some of the delivery semantics that delivery guarantees that Kafka comes with. There are producers and consumers. So in the producer side, they have async. One option is async. So in the async, you basically your producer sends a message to Kafka and then forgets about it. It doesn't know what happened, whether the message is stored or not, but it's a high speed as well. So the next one is that committed to leader. So you will have partitions, multiple replications. So when you send a message, it guarantees the one of the leader receives the data, and you get an acknowledgement from the Kafka. The third one is that mostly people want to have is committed to leader as well as followers. So that's kind of gives you guarantees that the message is received by Kafka. And there are always trade-offs on all of these options. If you want to receive data from a sensor every half second, you probably want to use async there. Even if some data misses, suppose your Kafka didn't receive the message, your producer sends the data and Kafka didn't receive, so you probably miss the data, but if it doesn't harm you, then you probably want to go for async, and that is high performance. Now, if you have financial data, where you want to make sure that every record is received and it doesn't miss, then you probably want to go for committed to leader as well followers. So and like I said, then probably your the last option might be a bit slower than compared to the first option, because then your all these Kafka cluster need to make sure that all this replicated data receive the data. So there is a trade-off there. On the consumer side, then you have certain delivery semantics. So there is called at most once, where basically doesn't guarantee that whether you will receive all this data always, and at the max time you get once. The second one is at least once, where you kind of gives you guarantee that you will get the message at least once. And the third one that mostly people want is exactly once, but this is currently possible if you sending data from one topic to another topic, then your Kafka makes sure it's exactly once. Getting this exactly once is a bit of hard when you difficulties. There are a good amount of difficulties when you try to implement that. And we'll see a little bit, there's a concept called idempotent. You want to make sure your consumer is idempotent. You want to make sure your producer is idempotent to having this exactly once feature. So in at most once, what happens is, suppose you have multiple messages stored in your partition, right? And then you have a consumer A, which receives those data from these partitions and push the data to some database, right? And your consumer gets the data in a batch. So suppose in the first batch, we get 5 messages, right? So 0 to 4, we got 5 messages. And then what happened is this, suppose after the consumer receives this 5 message, and then when it's processing to the database synchronously, after 3 messages, it failed, the process between microservice and database failed for some reason. In that case, what happened is these two last, so 0, 1, 2, these 3 messages processed to database, and the last 2, 3, 4, they actually missed, because in the at most once, Kafka will, the moment consumer receives those 5 in a batch, immediately Kafka will commit that, hey, my commit offset is 4, I have received these messages. So, and 3 or 4 didn't go to the database, so you actually missed these 2 messages. Now, the at least once is actually the little different. So now the consumer receives all these 5 messages, and then first it processes all these messages. When it is successfully processes all these messages, then it commits that, okay, I'm done, I have successfully stored all this data. Now in this case, how it works, so you have another same partition sending data to database, and then the batch came. Now in this case, you pick the first one, the batch comes, consumer process 1, 2, 3, 4, and then says, okay, 5 is done, 4 messages are done, now I want the next batch. Then Kafka said, okay, fine, you can start from 5th position now. So it pulls 5th, 6th, 7th, and now suppose your system crashes, the consumer crashes. So this time, Kafka doesn't know that how many actually been processed. So consumer A crashes and then says, hey, what do I start? When it restarts, your consumer spinned up again and the restarted machine and then said, hey, where do I start? From where do I get all those messages? So Kafka knows that 4th was his last commit. So he will say, oh, okay, you need to start from 5th position. So you go 5th, 6th, 7th, and 8, 9. Now this time you ended up getting duplicate messages. So 5, 6, 7 is your duplicate message. Now, in order to handle this, you can actually manage this by making your consumer and Kafka work together by making your consumer something called idempotent. So you can have your ID. So if you're storing the data in Elasticsearch, right? So you might be creating some EUID, right? So every time a new message comes, it generates a new ID and store in Elasticsearch. But if you deal with, if you make it the ID in such a way that every time it commits, it goes with the ID and tells that Kafka, hey, this is my ID and this is the last message I received. You can make it, and there are ways to deal with that. Okay. Yeah. So the topic is basically just a logical name. The partition is where the data is stored. Partitions level. Yeah. 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 Okay. So schema registry is now with this with when you sending data to Kafka is basically Kafka knows only one thing, that's stream of bytes. It doesn't know whether the data is string, integer, or double, or whatever it is, right? So when you have Kafka, let's say producer sending some stream of bytes to Kafka, and then you have a consumer receiving these bytes in the consumer side, right? Now you might have a situation where your data is sent in a string, but the consumer is expecting a number, and you get a number format exception, right? So this is an example, but there are tons of other things that schema registry offers, like so here's in order to solve that problem, what you do is basically your producer tells Kafka that this is how my schema looks like, and then consumer also register to that schema, and so that's how they know that what is the actual schema, entity schema, or however way you design it. They both know each other, and you kind of maintain or deal with those failures. So other than that schema, so what happens is your producer writes the schema to the schema registry. Schema registry stores that schema information, and then consumer reads the schema information from the schema registry. So in schema, when you start using schema registry, then you get different way of serializing your data. So Abro is the one you need to use in order to use schema registry. So there are ways to send data. You can serialize as a string serializer, or you can serialize as JSON serializer. Now you might not want to do a JSON serializer if you have tons of hundreds of thousands of data you are getting per second. It's not that efficient, right? So you probably want to use Avro serializer, which will squeeze the data, even make it a smaller size, and transfer to Kafka. And this also will tell you that, hey, if you are sending a data like creating a string data into integer data into a string format, then it will fail before you actually send the data to Kafka. So it gives you those options as well. Okay, so we saw schema registry. Now, some of the common usage, other than having your microservice communicating with each other, is this: that you will probably have some database, SQL database, where you would read data and write to Kafka, or you will have a use case where probably your microservice is feeding the data to Kafka, and you want to read from Kafka to Kafka topic to your different data storage, right? And then you have read data from Kafka and write to Kafka. That's also might be a use case. And we'll see in a second how that is possible, and how easy it is to build make this communication between topics to topics within the Kafka. So, and read data from an application and write to Kafka. So that's also like microservice sendings an event to Kafka topic, right? Now, in order to achieve these things, so if you have a read data from database and write to Kafka, you can write a producer, read the producer, fetch the data from database, and then sends to Kafka. You can write a Spring batch with JDBC item reader and Kafka item writer. And then that's one use case where you probably want to write a producer, but then there are certain difficulties as well. Right? These are very common use case. So if every 100 companies are doing the same thing, so it's kind of a calls for a different API which comes out of the box, and you just connect it, right? Similarly, for read data from Kafka to write data to DB, you probably want to use a consumer, right? So all of them are producer and consumer. And the write data from Kafka to write and read from Kafka and write to Kafka, you will have a producer which producing to Kafka one topic and consuming from one topic and then producing to another topic. And then read data from an application, there you will also have a producer, right? But then then there are certain things that Kafka provides. Is that that's what the so that's another example that I've already talked about. So some of the, let's see. Okay, so that's where the Kafka Connect tool comes into the picture. That kind of reduce your work, that you don't have to write bunch of producers and consumers. So for these common sources where you have a SQL database, Kafka Connect provides option to pull data. You basically just sends the information to Kafka to say, hey, this is my source information, this is my database name, ID, password, this is the table I want to read, and I have an example that we will see in a second. And similarly for destination, you may have S3 bucket, or if you want to store some bunch of files, or SQL database, or Neo4j, GraphDB, or whatever you want to store data. So Kafka Connect actually is, again, it's an API where you actually has bunch of endpoints. The connector is the most commonly used endpoint, where you send basically you make a post request to connectors endpoint. The most popular one is the source connector and sink connector. So in the previous slide, we saw that there are some use cases where you want to read data from a database and then sends the data to Kafka, right? So instead of writing your own producer, you can use source connector. Similarly, if you want to read data from Kafka topic and writes to a database, then instead of writing your own consumer, you can use Kafka's sink connector, and it's just with a very small configuration, it's just kickstart and puts data, collects data and put into the database. The connector is mainly focused in the streaming data from Kafka and database, and you can also write your own connectors. You can build using the consumer and producer API, but you probably don't want to, because Kafka already created this. Why to reinvent the wheel, right? So how do you use this Kafka Connect API? Now suppose you have a use case where you want to read data from a database table and then writes to Kafka, right? So as you see in the first, you can simply create one configuration file and have a curl command, and you see the first line is basically the user link to the Kafka Connect API. So you send the connectors, you give bunch of options, incrementing column name and in timestamp column name are the most important thing here to note, because the Kafka connector, source connector, the way it works is it needs to be told that which table you want to read from and what is the mode. So if the mode is incrementing, it means that every new records that comes to the table, it will pull from the table. And the way you tell by actually providing the primary key of your table. And now if you want to do a really data streaming, where basically you want to read either a new record or the updated record for every messages, then you want to tell connectors that, hey, my mode is incrementing plus the timestamp. So you want to say that updated table, or and the updated add column or created add column, whatever the timestamp column that you have in your tables. And then you provide some of the basic settings, like the password, username, and then the database name, database URL, that kind of makes the connector. And that's all you need to do in order to pull data from one database and put to another one. The sink connector is very similar. We have the same fields with a little bit of differences. You give the username, password, URL, etc., and you are kind of done with that. It's as simple as that. So some of the connectors that come out of the box, Kafka has created this for us. So JDBC source connectors that we saw the example just now. And then there is a sink connector. We saw an example of that as well. And then there is Elasticsearch sink connector. You can, if you want to push data to Elasticsearch from Kafka, you use Elasticsearch sink connector. And then Debezium source connector is kind of gaining a lot of popularity, so I thought I'll put this one as well. So what this guy does is, so it can actually capture the change data, capture the transaction log from your database. This makes it really in a true sense of event streaming, right? So all events comes in, creates, update or delete, everything happens is captured from there. And you don't have to build any system, you just spin up that, write that configuration file, and you have it ready to go. But there are some issues, like if you accessing some third-party external databases where you don't have the CDC enabled. So how do you get the data, and you don't have, and we had a situation, I would like to share that experience. So we had a situation where I had to pull almost 100 GB of data every night from a database, from some 7 or 8 tables. The problem was that the database doesn't have any primary key column, neither they have any timestamp. So we didn't really have any option to do a true sense of data streaming. Their database, these are views, and the CDC was disabled. So what we did is we used Spring Batch there, and kind of grabs the data, throw the entire table, pull the entire data every day, and using Avro, by making the serialization faster, it kind of made it much better. There are tons of other sync connector and source connectors available. If you go to Confluent Hub, you will see there are tons of spooldir is one of them that makes for reading data from CSV files. And then for Neo4j, GraphDB is also kind of very well known. So if you're looking for Neo4j connector, Confluent Hub is the place. MongoDB source connector, all of them, they kind of created source connector, sync connector. Okay, so the Stream API was introduced, I think, version 1.0.11. So now, earlier we saw that there could be a use case where you might want to read data from one topic, then make some changes, calculation, and then push it to another topic, right? That's where the extract, transform, and load come into the picture. And you can literally do this by using the Stream API with writing some Java code. The Stream API is a jar file that Confluent gives you. There's a K-stream and K-table. These are the two main classes that you would use. And yeah, this stream, this transformation becomes a lot easier when you have topic-to-topic communication. So some of the feature that, so I have already talked about this. So the latency between these two topic communication is almost like a millisecond. When you use a Stream API, if you have two topics, then the exactly one's semantics is taken care by Kafka. So you don't have to worry about duplicating records or missing records. The event sourcing and CQRS design pattern that we are using nowadays in microservices is also possible by using a Stream API. Now, I thought of adding some slides, but then I realized that it could be itself is a talk. So if you are looking for that, then we can have another talk about that. The third thing, the next thing is that KSQL. So Kafka has this concept called, I guess it's Kafka structured query language, maybe they call it. But if you have users who are mostly only familiar with SQL databases, and you don't want to piss them off by saying, hey, I want to use Elasticsearch, you have to write some bunch of DSL queries there, learn Elasticsearch, or learn some MongoDB's how to write queries, etc., etc. Kafka also provides a Kafka SQL, which they have started recently, and it has its own server, it has its own fault tolerant mechanism, etc., etc. And here's an example that I picked from Confluent Cloud. If you see the screenshot there, you can see how you can write a SQL query. So it's very much exactly the way you write a SQL query in your databases. And you can do a lot of other stuff like joining multiple topics, joining multiple streams. You can do those things also. But I think it takes a little bit of a learning curve. If you're very much familiar with SQL databases, then for you, this tool is only for you, right? Okay, so now that we saw that all these huge, the size of Kafka is like an animal, right? A huge application with so many brokers, and then you have multiple horizontal scalabilities. How do you install? Where do you use this server? Well, on-premise, if you want to use on-premise, then I'm not sure if that will be really practical. But we live in the world of cloud computing, so there are tons of people there providing options. The one that I think is in my opinion, is probably the best today is Confluent Cloud. But for development purpose, if you are a developer, you just want to spin up a Kafka cluster in your own machine with one single node, then Confluent CLI is pretty good. You just if you're using MacBook, you probably want to use Homebrew. Just install it, and Kafka Confluent start, and boom, it will start running. Will have a running cluster immediately. Confluent Cloud is kind of a little bit expensive, but is really good in they're doing the real Kafka architecture. They're following the architecture how Kafka should works, and they're the one who is following that architecture. And Confluent is the company who actually created the Kafka Apache Kafka project. Amazon MSK is another option. You can use Amazon managing streaming Kafka, but you probably want to do some research before you want to use that. There are tons of talks about this. The other one is Ivan Kafka is kind of cool in terms of if you're just beginning with Kafka, you have less amount of data, you don't have too many things going on. It's a great point to start, and then you can decide where you want to go. Pretty cheap. I'm using Ivan Kafka. Okay, so now it is time to demo. What we're going to do is we're going to connect a microservice which is going to read data from Twitter and then stream the data to Elasticsearch. So let's see. So I have my consumer running and producer is running as well. So what we're going to do is we're going to see that people, how many times somebody tweets about Techlahoma, right? And we're going to make the count in Elasticsearch. So what you're going to do is I'm going to say, okay, tweet. First, I'm going to show the thing that is happening, and then we'll go for the code a little bit. So what I'm going to say, okay, Techlahoma is awesome, right? Do you guys all agree with me? Okay, so I'll tweet it, and the Twitter was sent. So let's see what is happening here. So I just got a message that's created, and this is my consumer. So I'm going to go to Elasticsearch, and what I have is I have given a setup, and I created a matrix. So I got 7 count that tells me that I have received a message. Somebody tweeted just now about Techlahoma, right? So how we are doing this is, so I have a producer. This producer has, I'm basically using a library called HDBC. Is developed by Twitter. Is available on GitHub. I pretty much copied, pasted the code, and gave some information. I created a profile in Twitter developers. I had to tell them that, hey, this is only for my demonstration at the Oklahoma Java user group, and this is not for any commercial usage. So we are all good about that. And then you have a bunch of settings that the create producer, when I'm creating the producer, the cluster that I'm using here in this example is Ivan Kafka. So Ivan Kafka by default gives you key store, trust store to provide SSL security. And so you basically have to give bunch of information. You attach your key store, trust store files to the object, and then send it to Kafka. And that's pretty simple, you know. If you look at this, that what I'm doing here is that here's a Kafka producer. Gets the producer from those settings, and then I'm just simply running a while loop where try to Zoom out. Okay. Okay. Let's see if I can. You know what? I'm gonna make it in presentation mode. Does it look better? Cool. Okay, presentation mode. Okay, so this blocking queue, that code that you see, I got it from GitHub. Is there? You can copy paste and use that. The client as well, and then here is a bunch of the consumer key secret token. You get it from when you create a profile in Twitter, and then you basically just set those things. And then you here is what I'm doing: Kafka Producer.send. Now this example, I'm using only Java. I'm not using Spring Boot here. So if you're using only Java, then you can simply create this Kafka producer and send the data to send the data to Kafka. So Twitter topic is the topic name. If you see the code Twitter underscore tweet, and the message is basically the message that you get from Twitter. Okay, so let's see. Presentation mode, and then let's go to the consumer now. Okay. So the consumer is where I'm using Spring Boot. Okay, now this is not the consumer, sorry. Okay, for some reason let me close the other one. Still in presentation mode. Oh, this is the one. Yeah. Thanks for volunteering. Okay, so so I have a tweet consumer service. It's very much like I have bunch of configuration here. Um, so I have an Elasticsearch configuration where I'm basically connecting to Elasticsearch, and then Twitter configuration, which it comes with bunch of options, and it reduces a lot of work. As you see that I'm using Spring Boot's Kafka properties. You can just put all your most of your configuration information in the Spring Boot properties file, and then in the consumer, you are basically listening to the Kafka topic here. So you receive this data as a payload from the Kafka topic, and you are sending to here send tweet to Elasticsearch is how tweets Techlahoma is my Elasticsearch index, and I'm sending this tweet each by one. Now here's one thing that I didn't do is, if you also want to send all those that batch that you received from Kafka, you can also listen in a batch by setting that batch listener equals to true, and then sends that entire batch to Kafka Elasticsearch as a bulk create options. Okay, so so now here is a so we saw that in Elasticsearch we receive the data, and I created a visualizations here. You can also discover a bunch of information that if I want to see the text, that should tell me, let's see, text. Okay, so that's the old one. I just want to show the text that I created. I'm sorry, what's that? I'm just looking for the text. Oh, okay. So what is the question? Sorry, what's the question? Oh, no. I'm doing only the text Techlahoma. So the question is that from Twitter, when I'm sending the data Techlahoma, am I extracting the text Techlahoma or at Techlahoma? So I'm extracting only the Techlahoma word. So not second to last one. Okay, so I'm getting a lot of second to last one. This one. Okay, so not I don't see the message here. It should be okay. There you go. So finally found the message. Yeah, that was my demo. Yep, that's all I have for the presentation, and now I'm ready to take any questions if you guys have. Okay, question. No, we are not using. So the question is that, am I using Kafka connector in production? We haven't started. We're still in the in staging. We have a Kafka connector using. Okay, so the question is when we have a KSQL and how do we deal with the TTL? Now, the thing is that the way you create these streams in Kafka topics, that by providing the create update information. So you kind of don't get enough option that you write by yourself. But if you're using cloud provider like Ivan or any Confluent, I think Confluent is gives you options to solve those problems. They, I'm not sure, but I think there is a when you create a Kafka cluster, it comes with bunch of topics by default, and for those configuration like commit offset etc., they store those information in their own topics. So the can you come again? Sorry. So the question is that, are we using our own Kafka cluster or we are using some cloud service provider, right? Yes, we are using cloud service provider. We tried to see options, and I think it didn't make any sense to have a Kafka cluster in on-premise. We looked at Amazon to set up a bunch of EC2 container, but it has a lot of overhead. So if you pretty much, I think Netflix has a team of engineers just to maintain those Kafka brokers and clusters. So you probably want to go for cloud provider if there is a small team, and we have a very small team, so we went for cloud provider. We are using great question. So which cloud provider we are using and why we are using? So we are using Ivan Kafka. The most important reason that we are using Ivan Kafka is because we are at the very beginning stage, and it's the cheapest option. Yet it has good review by other people are using. However, what I heard is that Ivan Kafka's, the way they create their Kafka cluster is all VMs are co-located. On the other hand, if you use Confluent, then you get the real benefit of all those multiple VMs and etc. etc. But Confluent was a bit of expensive in terms of what we wanted to do, which is why we went for Ivan Kafka. So are we using KSQL in production? Again, this is also, we haven't started. Most of our Kafka stuff in staging environment, and we haven't started using KSQL either. I mean in production, still in the early stage. So when you're working on streaming data, how are you dealing with you have multiple consumers at the same time? Events getting processed out. Events getting processed? Out of order. Well, making sure that say you have 5 consumers listening to a Kafka user, and messages come in, but one of them running slow. Right. Right. So the question is, how do we deal with our consumer? Is some consumer is slow, some consumer processing faster, and from a particular partition when they're in a group, right? I think that's the most benefit of Kafka, that Kafka's partitions, the data is guaranteed to be ordered by the offset, and then the timestamp that provides itself some of the concept, like your the timestamp is generated in Kafka. Uh, and then compared to other messaging services, I think that's one of the thing, that if you have some consumer is slow and one is processing faster, so Kafka is, you can, the ability to replay event, replayable options, that if for some reason that your consumer wants to one topic which is sending data to Elasticsearch, another consumer is sending data to Postgres database, and somehow it didn't miss, you can replay those events from Kafka topic. Okay, so the question is that if let me first understand if I understood the question. So you have multiple consumers consuming from the same topic, right? You have multiple partitions, and partition 1 giving data to consumer 1. Partition 2 is giving data to consumer 2, right? Now, if partition is consumer 2 is slow, then consumer 1, both of them are in the same group, right? Consumer 2 is slow, but the partition 2 is giving data to consumer 2, right? Okay, so I think the partitioning, how Kafka creates the partition is basically Kafka does itself. We tell that how many partition I want. When I create the topic, that's when I tell the partition number of partition I want, and Kafka under the hood creates the partition, store the messages in the offset. So Kafka deals with that, the ordering of the messages. The automatic process of, I'm sorry, what was the question again? So are you saying that the partitioning is an automatic process? Creating partition is when, by default, it creates a one partition for you. But you can tell how many partitions you want to create. So when you have multiple partitions, you create multiple partitions, Kafka will put those different partitions into different machines. And those different partitions will receive data for each message, and they will have their own offsets. And the way, one of the slide I was talking, the way they create this or give the offset is partition number 012 and then the offset ID. That's how your message gets an ID. So that's how it makes sure that your messages are ordered. And I think that's one of the coolest feature of Kafka, is that it guarantees the order. Please. Oh yeah. You can in your consumer, that's kind of making sure that your consumer producer is idempotent. So you create an ID in your Elasticsearch, and then when you commit that with the partition number, offset, and the ID, you can commit that to Kafka, and that makes sure that this is where it starts. Yeah, I think so. So the question is that if your producer multiple producing data at a high speed, but the consumer is not able to keep up with the speed, how do you deal? And I think that's a great question. You know, that's probably is why Kafka is so popular. One of the another big reason that since you have this producer always producing to particular partitions, and this partition is append of logs. So, and it guarantees the order. So when your consumer, suppose processing synchronously, and one of the slide as I was talking, that after processing few messages, it broke and then restarted. So Kafka knows your, so there are multiple configuration options where your consumer can tell, so okay, I want to, this is the at most one, or at least one comes into the picture. If you, in a batch, five, let's say the batch is 5, so receive 5 messages, process 3, and then failed. How do you get those, then last, the messages which failed? So Kafka knows when what is the last process. Is there any tool for Kafka? That's a good question. Actually, I'm not very sure. Any more question? Okay.
Okay, well, this is it. Thank you very much. We appreciated the talk. I think we had record attendance today, so thank you. And just one more minute, we're kind of past the time, but we usually hang around a little bit. We have a lot of folks here today. Thank you all for coming. We really appreciate it. We're always looking for volunteers to present. So if you have any topic in mind, please, Jason over there is there, Brent, myself, or you can just simply post to the meetup. Or if you know anybody who will be a good speaker, just throw it out there or talk to one of us, and we'll be glad to get you on the schedule. So again, thank you very much. Very interesting talk, and we'll see you in about a month. Thank you, guys.